Okay, so these are a group of water questions that will be helpful in terms of your applied science Unit 1 revision. Two pupils, David and Haf, calculate the mean for a sample. So David and Haf were calculating the means, okay, and they both did it a little bit of a different way and got different means, okay. So David actually, if you look at sample B, David added them all together and then divided by 4, okay, and that's how he got his number. Whereas Haf removed the anomaly and added the 3 together and divided. Haf is more accurate by removing the anomalous result, okay. State which sample A, B or C is the least hard. That would be, that is wrong. That would be A, because it takes the least volume of soap to form a lava. State which sample contains both temporary and permanent. It's B, because if you look at the difference between B there and B there, there's a massive decrease in the amount of soap. So if it was just temporary, it would still be really low, but because it's half and half, it's decreased slightly but not enough. There's still some permanent hard water in there. Name the ions that cause hardness water: calcium ions or magnesium ions. So this is a 6-mark question. I've put it out as like a method to be able to collect optimum marks. It is asking about 3 different samples of water. One is temporary hard water. So straight away you should be thinking or writing by there, you can remove that by boiling. Okay. This one is a lot harder to remove. And then distilled water is actually a very soft water, okay? They were not told not which one, but they were told that temporary hard water is softened by boiling. Describe an investigation. So what I would do is I would measure out 5 centimetres cubed of each sample into test tubes. I would add 1 centimetre cubed of soap solution and shake it. I would then keep adding 1 centimetre of soap solution until a lava forms, okay? I would then record how many centimetres cubed I needed to form the lava. I would boil all 3 samples and repeat step 2 and 3. Permanent hard water would have a high soap solution, soft water would have a low soap solution, and temporary would lower after boiling, so you should be able to see which one is which. Suggest a reason why energy may be wasted in homes and hard water areas. Causes lime scale harder to boil the kettle. Again, some students are carrying out some work with some hard and soft water, and they want to work out which one is hard, soft, temporary, hard. State which water is the hardest and give your reason. It is A, because it doesn't soften after boiling and it requires a high volume of soap solution. Then it says, state which sample contains both permanent and temporary. Give a reason for your answer. It's going to be D, because it decreases slightly, but it doesn't decrease as much as you think. Okay, slightly lowers after boiling, but not completely. Then it says, describe how pure water is separated from seal water using the equipment above. This is a distillation setup. This is a distillation flask, okay? What will happen is that pure water will have a lower boiling point because it's got nothing else in it. So what you do is you heat up the sample of water, wait for it to boil and turn from a liquid to a gas. It will then boil through. It will then, because there's cold water running through here, it will then condense and turn back from a gas to a liquid, and then you will be able to collect your sample of pure water by here, okay? What you'll be left with here is salt, basically, and anything else that makes the water seawater. Suggest what you would see if you added 1 centimetre cubed of soap solution or added to 5 centimetres pure water. It should form a lava really quickly because it's very soft water with no ions present. Okay, so this question then is looking at comparing the solubilities of 2 different salts, okay? Below 54, okay, weird value, but they did 54, so 54 is going to be at this point here, okay? So below 54, they're both increasing. Even though sodium chloride's only slightly increasing, they are both increasing, okay? At 54, they are exactly the same solubility. Above 54, then, sodium chloride stays the same, whereas copper sulfate goes on and increases much more. Calculate the mass of copper sulfate that forms when a saturated solution of 50 grams of water cools from 80 to 40. So what you need to do is find the value for copper sulfate at 40. So I'll do it in a different colour for you. So 40 is going to be along there, and that's going to be 28, okay? And then at 80, again, draw a big line up. You're obviously going to have a really good ruler, unlike me. Draw it across, and that's 55, okay? Take them values away from each other. If it had said 100, then you would have just kept it. Because it says 50, you need to divide it by 2. Statewide temperatures of solubility graphs range from 0 to 100 because they are the melting and boiling points of water. So that's when water is in its liquid state. Again, another kind of question quite similar. Find the solubility of potassium bromide at 60. So go up and across, and that's going to be 84. Okay, this is a weird scale. It's going up in 4s, which is not a great scale. So that's why it's 84. A student places 200 of potassium bromide in 200 of water at 60 and stirs until no more dissolves. Calculate the mass that remains undissolved. Okay, so because this is 100, that's 84, so that's when it's at 100. So I calculated how much it would be if you had 200 grams. So I times it by 2. I then took that away from the 200 that we said we started with, and you ended up with 32. Again, the same kind of question. Why do we compare the solubilities at 0 to 100? Because this is the melting and boiling points of water. Water is used to dissolve the solution, so it needs to be in liquid form. Okay, same kind of question coming up all the time. Nice question then. Most abundant. Okay, that's a bit of a word that we might not have heard of before. That means there's lots of it. Okay, we're going to have chloride and we're going to have sodium. They're the most abundant, the ones with the highest numbers. Chemical formula for these ions. Okay, so it's Na plus Cl minus. You'll get that. Top, swap, drop. You don't really need to do it for this one because you can see it's the same charge, but I'll just show you the process, and then it would just be Na. You could have the little ones if you wanted, but you don't need them. Both chlorine and iodine are obtained from seawater. Suggests why it is too expensive to use seawater as a source of iodine. Concentration too small. Okay, a lot of water would have to be extracted and go through the process to be able to get any of the iodine out. Final question then, another solubility curve. Name the substance that shows the smallest change in solubility. Is this one. As you can see, barely anything is happening. Barely anything is happening. Sodium chloride. Give the temperature at which both potassium nitrate, so look for them, potassium nitrate and sodium nitrate are the same. It's where they cross over. If you draw a line down, it's going up in 1s, so that's 64. Another kind of question. Saturated solution of sodium in 100 grams is cooled from 80 to 100, okay, of sodium nitrate. So find it at 80 and draw a line across, okay, and that's 1 to 8, and then at 10, so find 10, which is going to be there, and that's going to be there, and that's a nice easy one, is 80. Take them away from each other, and that'd be 48. Describe using the data from the graph how the solubility of sodium sulfate changes with temperature. Okay, so sodium sulfate, look for it. It increases until 30 degrees. That's 30 degrees there. Okay, and then decreases after 30 degrees. So you're just describing what you see in the graph, but make sure you're using temperatures, key buzzwords like increases and decreasing, but pointing out what temperatures it increases and decreases at.